going to pick up again with our exponents. Today we're going to explore negative and zero exponents, but first let's kind of take a step back, look at what we did yesterday with our simplifying, and we're going to express our answer using positive exponents. That's going to be a new direction we're going to have using starting today. And when we simplify, let's use a process of expanding first, then simplifying. I think that's going to be good for us today to see the relationships. So we've got v squared times v to the fourth. Okay, so v squared is going to be v times v, and then v to the fourth is v times v times v times v, and they're being multiplied. So we see I actually have v times itself 6 times, which is going to make this expression v to the 6th. Now that's simplified. N to the third plus n to the third, those are like terms. We remember they each have a coefficient of 1. So 1n to the third plus 1n to the third would be 2n to the thirds. Notice the exponent doesn't change because we're not multiplying n's together. We're just adding two like terms together. On number 3, we've got 3 h's being multiplied and then 2 h's being added. H times h times h. H to the third. H plus h is 2h, so h to the third plus 2h. Those are unlike terms, so we are fully simplified. Okay. The number 4, 3x squared plus 3x squared, like terms. 3x squared plus 3x squared, 6x squared. And we have simplified. Something we want to learn as we're going through and we're working with exponents is, what does it mean for exponents to be simplified? What are we looking for when we simplify exponents? Okay, one of our rules is we don't want, in our final answer, we don't want any exponents with number bases. So for example, we don't want an answer with 2 to the third. Instead, we want to simplify that and say, oh, that's 8. That's simplified. We also don't want any parentheses. So an example like that might be having something like xy to the third. Instead, I want to expand that. Maybe regroup. And realize that that's going to be x to the third, y to the third. And that one was a little advanced for today. That's what we're going to do tomorrow. So let's just think of that example as a little bit of a preview. Okay, so we're going to keep this list and we're going to add to it as we go. We're just going to do a couple of problems on our own just to reinforce before we get to our notes in the booklet. So I'm asking you guys to compare two values and fill in the blank using less than, greater than, or equal to. So take a second and do that. First one, negative 2 to the fourth without parentheses and negative 2 to the fourth with parentheses. So let's expand and see what's going on. We know without the parentheses, that's really negative 1 times 2 to the fourth. So negative 1 times 2 times 2 times 2 times 2, right? 2 times 2 is 4, times 2 is 8, times 2 is 16. So negative 1 times 16, or negative 16. Now with the parentheses, that means negative 2 is our base. So it's negative 2 times negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4, times negative 2 is negative 8, times negative 2 is positive 16. So we're going to use this symbol. Negative 2 to the fourth is less than negative 2 to the fourth with parentheses. It's deceptive because we read them the same way. Now let's look at what happens here with negative 3 to the third and negative 3 to the third with parentheses. On the left, the base is just 3, so that's negative 1 times 3 to the third, which means negative 1 times 3 times 3 times 3. So that's negative 1 times 27, negative 27. With parentheses, the base is negative 3. negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is positive 9 times negative 3 is negative 27. This time, they're equal. So what's the difference? Why was our first problem not equal, but yet our second one was? It has to do with the exponents. Even exponent, right? Those parentheses make a huge difference. Odd exponent, the parentheses don't impact the final value of your simplified expression because we're multiplying a negative an odd number of times. So the result will be negative anyway. Let's do another example of our expand and simplify. Okay, so a little preview as to what we're going to do tomorrow. So first thing I want to notice that this is 4 times xy squared, where that xy is the base, meaning it's being multiplied by itself twice. So that's xy times xy. We should notice that x and y are also being multiplied, so I can show that. 4 times x times y times x times y. Look at those x's, look at those y's. Maybe I'll put them next to each other using our commutative property. 4 times x times y times y. Well, x times x, that's x squared. Y times y, that's y squared. And then times 4. Okay? Haven't changed anything. We've just changed how we're showing our multiplication. So here we're going to look at some patterns we find when we expand and simplify our powers to see if we can determine any rules of when we have a 0 exponent and a negative exponent. So let's start with our powers of 2. We know 2 to the 4th is 2 times 2 times 2 times 2, which is 16. 2 to the 3rd, 2 times 2 times 2, which is 8. 2 squared, 2 times 2, which is 4, and then 2 to the 1st is just 2, which is 2. So let's look at what happens there as we sort of walk down that ladder. How are we going from one to the other? Well, here there's 1 less 2. How am I getting rid of it? How do we go from 16 to 8? Well, we divide by 2. Okay. How do we go from 8 to 4? There's 1 less 2 there. We're dividing by 2. How do we go from 4 to 2? Well, we divide by 2. So each time we're dividing by 2, by one of the bases. So let's continue that here. 2 divided by 2 is 1. So 2 to the 0 power is 1. Let's continue that pattern to figure out what 2 to the negative first power is. 1 divided by 2 is 1/2. Continue the pattern to figure out what 2 to the negative 2 is. 1/2 divided by 2, right? Now remember, keep change, flip, is going to be 1/4. Keep it going. 1/4 divided by 2 is 1/8. 1/8 divided by 2 is 1/16. Now here you might notice something about our denominators. Our denominators are really, if we think about it, sort of that mirror image of what's going on top here, except they happen to be in the denominator. So 1/16 is really 1/2 to the 4th, because 2 to the 4th is 16. So 2 to the negative 4th power is just 1/2 to the 4th. Well, 1/8, 8 is 2 to the 3rd, so that must mean this is 1/2 to the 3rd. 1/4, 4 is 2 squared, 1/2 squared, and that 1/2, 1/2 to the 1st. Wow, that's really cool. Now, usually we'd say, oh, I'm trying to kind of come up with the rule here, but you really have to do more examples in order to come up with a rule. So let's take a look at our powers of 3, see if the rule holds. Okay, so 3 to the 4th, 3 times 3 times 3 times 3 is 81. 3 to the 3rd, 27. 3 squared, 9, and 3 to the first is 3. Okay, so here we did our pattern dividing by the base. Let's see if that works. So we're going to get rid of a 3. 81 divided by 3. Yep, 27. 27 divided by 3. 9. 9 divided by 3. 3. 3 divided by 3 is 1. So 3 to the 0 power is also 1. Now let's go again. Divide by 3. It's going to be 1/3. Divide by 3. 1/3 divided by 3. Think of that keep change flip again. 1/9. 1/9 divided by 3. 1/27. 1/27 divided by 3. 1/81. And again, we see that, oh, 81, that's just 3 to the 4th. So that's 1/3 to the 4th. 1/3 to the 3rd. 1/3 squared. 1/3 to the 1st. Okay? And the same thing works here with our powers of 10. Okay? So let's kind of take that rule and put it into place. And we do it algebraically. Any value raised to the power of 0 is 1. Even if it's a variable. X to the 0 power is 1. Any value raised to a negative power is what we call the inverse, okay, of the value raised to the positive power. So you've got that flip. So if we have something like x to the negative y power, our rule is going to tell us, well, right, 10 to the negative third was 1/10 to the third. So x to the negative y would be 1/x to the y power. Now we're on page 6. Let's take a few examples of our 0 exponents. Okay, so a to the 0 power, that's just going to be 1. ab to the 0 power, we have to realize b is the base, a is the coefficient. So that's a times b to the 0 power. Only b has that exponent of 0, so that's what's going to become 1. So it winds up being a times 1, which is just a. So ab to the 0 power is a. However, if we look at example 3, we've got ab in parentheses. So ab is the base, so the entire thing becomes 1. So again, naming that base, being able to identify that base is very important. Before we go and do some negative exponent examples here in the booklet, we're going to go back to our separate note sheet just to look at 3 possibilities of negative exponents before we look at the shortcuts here. We want to really look at the why. So we have 3 ways we encounter negative exponents. The first way is when we just have, a number with a negative exponent. I like to think of it as being the numerator. The second way is if we have a negative exponent in the denominator of a fraction. And the third way is if we have negative exponents with a fractional base. So there's sort of 3 different approaches we take there. And we've come up with a little bit of shortcuts to help us through. And this is really going to put those shortcuts into perspective and explain where they come from. So the first one, that example 1, we came up with that shortcut on our first page of notes, on page 5. We did that whole big table to say, oh, well, you just do the inverse. You put it in the denominator. 2 to the 3rd is 8, so it's 1/8. So if your negative is on top, move to the bottom, and make it positive. Right, so we moved that 2 to the negative 3rd to the bottom, and we made our exponent positive. The second example, we're going to use our first example to help us get there. So we start with 3 over n to the negative 2 squared. So our rule for that negative exponent was move it to the bottom and make it positive. So let's do that. So that's going to be 3 over 1 over n squared. Now you might remember, it's a complex fraction. Can't have a complex fraction. What this is really telling us is 3 divided, right? 3 divided by 1 over n squared. How do we divide fractions? Well, we keep, change, flip, which gives us 3n squared. So let's look for the shortcut in there. What did we do? Well, really what changed was we took our base with the negative exponent, moved it to the top, and made it positive. So that's our rule, right? We're going to move the negative to the top and make the exponent positive. So if we have a negative exponent in the denominator, we move it to the top and we make that exponent positive. Notice nothing happened to the 3 that has a positive exponent of 1. Whenever we don't see an exponent, it's that assumed exponent of 1. Okay, let's look at our third example, example 3, okay, which is that fractional base. Okay, so again, we're going to base it off of that first example, right? We said you have negative exponent, move it to the bottom, make it positive. So we'll do the same thing there. Take the whole thing, move it to a denominator, make the exponent positive. Notice I still kept the parentheses. The base is still 2/3. Well, this defies our rules of simplify. We have both parentheses and an exponent with a number base, so let's simplify that. So that's going to be 2/3 times 2/3, which is 1 over 4/9. Ooh, complex fraction, can't have that. That's 1 divided by 4/9. Keep, change, flip. That's 9 over 4. Okay. Now, just to help us with our relationship, I'm going to kind of work backwards. What's 9 over 4 in the relation of our 2/3 or our exponents, right? One way to get 9/4 would have been to do 3 over 2 squared, right? 3 times 3, 2 times 2. So let's look at our little shortcut there. What happened if we go straight from here to there? Well, if we have a negative exponent with a fractional base, what do? We flip the fraction and we make the exponent positive. Okay. So these are the rules we're looking at on page 6 with our negative exponents. These are the reason those shortcuts work. Okay, so I really wanted to make sure we had the y. So back on page 6, let's practice our negative exponent shortcuts we can put into practice. We've got example 1, 4x to the negative 5th. When we have a negative exponent in the numerator, we're going to move it to the denominator and make it positive. What we want to notice, though, is that the base is x. 4 is a coefficient. So that's just 4 times x to the negative 5th, which makes that 4 times 1 over x to the 5th, which is 4 over x to the 5th. There's our answer, 4 over x to the 5th. So we just move that x to the 5th in the denominator. Now that we've seen the example, you can jump right from that to that. Okay. Example 2, 3 over x to the negative 6. When a negative exponent is the denominator, make the exponent positive and move the number to the numerator. So we're just going to take this, move it up top, and make that exponent positive. Boom. There we go, 3x to the 6th. Nothing has to happen to the 3. It doesn't have a negative exponent. Okay. When a fraction is raised to a negative exponent, switch the numerator and denominator, make the exponent positive. So that's going to make that 3 over 2 to the 4th. And then let's simplify it. So we expand it, 3 over 2 times 3 over 2 times 3 over 2 times 3 over 2, which is going to be 81 over 16. Excellent. Okay, let's put into practice now with simplifying. And notice we're going to keep those same directions of simplifying, but we're going to use only positive exponents. So our definition of simplifying from our do now, which I'm going to grab right here, I'm going to add to it. Simplifying, no negative or 0 exponents. So if we have something like x to the 0, we're going to make it 1. If we have something like x to the negative 2, we're going to make it 1 over x squared. Okay, and that definition of simplifying is just going to keep building. Okay, so 7 to the 0, that's just 1. Anything to the 0 power is 1. Negative 7 to the 0, that's negative 1 times 7 to the 0. So that's negative 1 times 1, which is negative 1. If I'm going too fast, pause. Take a second. Slow it down. Okay. Negative 7 to the 0. Negative 7 is the base, so whole thing becomes 1. Number 4, a times bc to the 0. bc is the base, so that becomes 1. A times 1, just a. 4y to the 0. Y is the base. That becomes 1, so 4 times 1, 4. Now this one's good. This is a good one. 4y to the negative 2. We've got that negative exponent's base is y. There's a times 4. Guess what? Don't care about any of it because it's all the base of that 0 exponent, so that whole thing becomes 1. Boom. Easy problem. Then we've got 7x to the negative 4th. That's our first rule of negative exponents. We're going to take it, put it in the bottom, make it positive. There we go. We're fully simplified. 8, this is a good one, like this. Okay, so we've got a negative exponent in the denominator. We're going to take it, move it up top. Look what that makes. That makes x squared times x to the 3rd. Interesting. Let's expand it. See what that is. That's x times x, then times x times x times x. That's really x times itself 5 times. Boom! It's x to the 5th. Ooh, don't you love exponents? Okay. Notice here on 9, the base of the negative exponent is just x. So that's the only thing that's going to move into the denominator. That 2 is going to stay in the numerator, making it 2 over x to the 1st. We never actually write exponents of 1. We know it's there, though, when we don't see it. So it's just 2 over x. Okay. And then 10, 3x to the negative 2nd power. The whole thing's the base, so we'll move the whole thing down. Make our exponent positive. I think we can simplify that. I think we did an example similar to that before. I think we can do that. Let's practice it. That's really going to be 1 over 3x times 3x. Let's expand again. 1 over 3 times x times 3 times x. Let's use our commutative property. 1 over 3 times 3 times x times x. That's going to be 1 over 9x squared. That's beautiful. Just step by step, step by step. Okay. And then 11, fractional base, other exponents in there. All right. So let's flip it. Make our exponents positive. And expand it. That's y to the 3rd over x squared times y to the 3rd over x squared. Interesting. I think we can figure that out. Let's say when in doubt, expand it out. Make it one fraction. I know y to the 3rd is y times y times y. Our other y to the 3rd times y times y. X squared, x times x times x times x. Let's see, that's y times itself 6 times over x times itself 4 times. Some of you might be starting to notice a few patterns as we multiply our exponents with same bases. That's what our lesson tomorrow is going to be. Okay. And then last one, 5x to the negative 3rd. The base of that negative 3 exponent is just x, so that's the only one that moves down. 5x to the 3rd. Good. Okay. So as you go and do your classwork today, definitely take it slow, right? Use your notes, have that out in front of you, replay the video if you need to, follow those directions of simplify we were talking about, and make sure you check your answer key, okay? Let me know if you guys have questions on this stuff. Our math jokes for mathy folks today, another one-liner. The man whose best buddy is an abacus has a friend he can count on. Get it? Abacus? Counting? Good stuff? All right, guys, have a great day.